Okay, for the sake of logic and coherence, I'm going to run through these really fast so you can get kind of what you need out of it without like getting into all the like technical crap. So what we're doing today is we're identifying odds and even functions. And I wrote out here that even functions are reflections across the y-axis, and odd functions are 180-degree rotations around the origin. So if you're looking at a graph and you want to tell if it's odd or even, if it has, first of all, if it's odd, it also has to have an odd degree, and the even has to have an even degree. So you can tell by looking at a function whether it's odd, an odd or even degree. You should be able to identify that pretty quickly. So this is an odd degree polynomial. And then if you want to know if that odd degree polynomial is actually an odd function, what you're going to do is you're just going to flip your whole paper upside down. So take your notes sheet, turn it upside down right now. And what you should notice is that this graph looks the same upside down as it does right side up. And so it is an odd function. For an even function, the way that we can tell if one is even is if we take the function and we fold it in half on the y-axis, so it reflects across the y-axis, then all the pieces over here should touch all the pieces over here. And then finally, if we look at C is an odd degree polynomial, but when we turn it upside down, that y-axis moves from above to below. And so this one is a neither function. So now if we're going to identify odd and even functions from their equations, we actually are going to do something algebraic. And what you need to know about odd functions is that if you plug in negative x for x, then you should get out the whole function should be the opposite. And then for even functions, if you plug in negative x, it's going to equal the same function. And basically what you can do is you can look at a function, and if every degree is odd, then the function is odd. And if every degree is even, then the function is even. And even degrees include constants, because remember 8 is the same as 8x to the 0, because x to the 0 is just 1. 1 times 8 is 8. So if I look at A, what I notice here is that we have x to the 5th, but then we have x to the 0. X to the 0 is even, and so this one is going to be neither. But if I wanted to prove that algebraically, I would say 4, and then I'd put in negative x to the 5th plus 5. And negative x to the 5th is, so negative x to the 5th is going to be negative x to the 5th, because there are 5 negatives, so that makes it negative. So this is going to be negative 4x to the 5th plus 5, which is not everything opposite. But so down here, I've got an odd power and an odd power. So this function should be odd. So if I get 2 times negative x cubed plus 3 times negative x, this is negative 3x, and this is negative 2x cubed. And so that both of those have they're opposite of what they started. So because the whole thing is opposite, it is an odd function. Transformations, you guys should be really comfortable with. So this 3 right here is going to stretch it by 3. Let me spell stretch right. And then that negative 18 is outside the parentheses, so we're going to go down 18. And that's exactly what happened. So this got skinnier, it's stretched, the green is stretched, and it went down. So for B, we're going to stretch by 5. It helps if I can spell stretch. It is going to go right 2 and up 4. Oh, I should do that in a different color. Sorry. Up 4. You guys know how this works. And so this one is a transformation. And really, when you're worried about transformations like this, you're only worried about what's happening inside and outside. So this is obviously a cubic function. It's a negative because look at the behaviors, guys. It's going down, it's decreasing. And then our x was moved 3 to the left, and our y was moved down 1. Here, we'll say that this is a quartic because it's even. So we're going to have a quartic. It's also negative because end behavior down. And then our x was moved 1 to the right and up 5. And then we don't really care about example 5. So there's all that you need to know. Hopefully this is enough to get you through. Rewatch it if you're lost, and I will see you next class.